going on with Venus. Had a part of it just rip off, and an amateur photographer caught it. It's a pretty cool story. We also got a geomagnetic storm incoming here in the next couple days from some more eruptions on the sun. And we got some pretty cool Aurora pics I'm going to show you from the last one from all you guys. So, yeah. So let's just kind of get started, guys. Somebody give me a 5 for 5 in there, and we will get going. And why I do that, I will also say thanks to Aaron. Even before the stream started, he gives 5 memberships. Awesome stuff. Awesome stuff. And for anybody wondering, yes, I'm okay. Okay, I'm not gonna like talk a whole lot about how I was feeling yesterday and today. I took care of everything. Okay, so I'll just leave it at that. I'm not really feeling the greatest. You guys can probably hear it in my voice a little bit, but I am still running a little bit of a fever. But that's it. We're not gonna go any more than that. We're gonna stay positive. But yeah, guys. So we've had that. You know, this really interesting story with Venus. It really kind of caught me by surprise also, you know. And as we got the sun facing us with this rare sunspot, we do have the eruptions yesterday. The models are now in, and they are forecasted to hit. It doesn't look like it's going to be very strong at this point, but all of that could change. And also, guys, right after this stream, I'm doing a members only stream. Okay, so if anybody joins now or whatever, just remember right after I'm going to jump right into a members only stream. We're going to watch some Zoom court hearings. We're going to try to pick one out together, I guess, or I could pick one or whatever, and we're going to watch it together. It's really, really interesting. So yeah, I'm also going to try to show some Aurora pics for you guys too. Miss V, thank you for sending that in for Dennis. Dennis, if you're here, buddy, those were really cool Aurora pics. So thank you, Miss V, for facilitating that. That was really cool. So anyway, guys, let's just get into this, okay? So as we're going through here, guys, just remember that this is solar maximum, right? We're in that time frame. I think it's pretty safe to say that we're in that area of solar max. I think once they go back and look at the data, I think we're kind of at maybe the first quarter of it, maybe just kind of at the beginning, because the sunspot numbers still keep going up. Okay, and that's how they judge that. Just for a little bit of a reference right here. Okay, this is NOAA space weather prediction. So what we do is we go over here and we look at the number of sunspots. They plot it each month. I've shown you guys this thing a bunch, and here's the forecast. Right, the red line. Yeah, but they give themselves a window of possibility here. So I'm not sure exactly what the percentage is, but anywhere in that gray shaded area, they would consider that still on point for the forecast. So we really did. If you use that, we kind of stayed close there, but it was always at the high end of their little window they give themselves. But then this happens. Okay, the last 4 months have just been completely plowed way up here. Even back here, guys, May of 2023, June of, that's May still, 137 in May, June is 160, July, 160, that was 2023. Now, you can see here in 2024, they're even higher. And then, July 2024, almost 200. And that's the official number that it came in at. It's way above anything close to what the last sun cycle had. It's 50 sunspots above it, above the max there. And they were forecasting us to have a similar sun cycle. So, yeah, things are more active than expected. And we're probably going to see the butterfly effect. And I'm not going to show you what that is. It's actually a different graph. And it looks like a butterfly. But we get 2 different spikes. Okay, we'll get 2 different maxes, but it's all in the same solar max. So what we'll see probably at some point, it'll drop down for a month or so, and then it'll pop back up, and then it'll start its decline into solar minimum. Okay, that's what we would expect to see anyway. So not sure if that's what will actually happen, but yeah. You know how that goes, right? We will start right here, guys. This is the X-ray flux, and as we're looking at this, this is how we do. This is how we measure flares. That's how we assign them a class: A, B, C, M, and X, and it's done by the amount of X-ray it puts out. X-ray gets here in 8 minutes from the sun, so there is no warning given for flares. Okay, if you ever see a picture or an image of the sun and somebody's saying, "Hey, that's an X flare," because of that looks like an X, that is wrong. That's just a camera anomaly. You can get that same X anomaly with the camera from some of the cameras, and we see it often with a C class or a B class flare. An X flare is the way they rate those is solely off of the amount of X-ray detected. Okay, so with that being said, obviously this is a warning system over here, or a storm level system. That's radio blackouts. That's what this causes. Okay, and other things, but this is what they go off of. So you got R1, R2, R3, all the way up to R5. R5, yeah, that's a big, that's a big X flare if it happens like that. I'm not sure if we even got into an R4 yet this cycle. I know we got to we've had multiple R3s because that is the bottom level. I think we did, guys. I think we got to an R4. I have to go look, but I don't know if we got to an R5. Now, this is different than a G5. G5 is geomagnetic storming. That comes 2 to 3 days later from the CME, the high-speed plasma. Okay? Yeah, I know I did. I started just a little bit early. I want to try to get the members-only stream in there, Kathleen. I'm sorry. Guys, remember that when I'm doing, I try to schedule these out, and I put the thumbnails out, guys, so you know. I want to give myself at least a half hour from the time. Yeah. If I start within a half hour of the actual time I put in there, it'll send you guys 2 notifications. So I have to schedule it for I have to try to guess like a half hour before I get here. But when I post it a day or so early, I'm just giving you guys a ballpark of when I'm going to be here. That time's most likely it's going to be real close, within an hour or so. But the way my life is, I can't, 30 seconds right here, we're starting at this exact moment. I wish I could, but I can't do that. It's just the way that my life, I got a family and things happen, and I don't want to say, hey, I'm going to be here at this exact time, and because I was doing that for a very long time, and I very seldom was I able to be there at that time. So I don't want to do that to you guys. So remember, when I do that, within an hour or so, and if you look over at it, every once in a while I'll come in here, and if I think I'm going to be a couple hours late, I'll change that time so you guys can see it. I'm not going to just not change it and then show up 2 hours later. I will change that, just so you guys can know that. So I do apologize for that, but that's all I can do with that, guys. Wish, yeah, sometimes I wish, I wouldn't change anything I got going on with my family, but it does make it difficult sometimes. So right here, guys, we've been talking about this coronal hole also. This coronal hole here, we were connected to it. We got one down here now too. So we're probably connected to both of those at some point. And what that's going to do, it's a hole in the corona. The sun is actually, the surface is colder than the atmosphere. And that's why it's black on this image. Okay? The darker colors are the colder areas. So what it does is the atmosphere of the sun, the corona, opens up, and then high speed and highly charged particles just flow out from the surface. That's how that happens. Okay? And when it gets here, it's called solar wind. It's a pretty normal word, or a basic word that we use around here. And it can put us into geomagnetic storming on its own. A lot of times what it'll do, it'll enhance like CMEs when we're getting hit. We have to have some geomagnetic activity to stay safe anyway. We want to be, if you guys look at this is kind of really what we want to see. We want to be kind of in the middle. We want some geomagnetic activity, but not too much, right? Because it actually helps protect us. Some geomagnetic activity. If we have none, and then we get hit with just a massive solar storm, it can get really intense really, really quick. Plus, this actually will help deflect cosmic rays. And cosmic rays, we'll talk more about that as we get closer to solar minimum. And I'll probably talk about it before that anyway, because I typically do. But they get in easier. Geomagnetic activity actually helps deflect those things. Okay, so let me just jump in here, and I'm going to show you guys this sunspot, right? So this is the sunspot we've been talking about. This broke the law, right? So let me show it to you, the eruption, because I know it's what people want to see. So we're going to start here with this eruption. Let me see this for a second. I can't really remember what time that happened. So it'd be what, 3, 6, 9, right around 9, 10 UTC time there when that, so it would probably be this one. Or maybe even this one. I can't really remember, but we're going to look at all of it. So we'll just look at this one. That was off, that, I talked about this yesterday. I'm not going to sit there and reiterate this one again. But this is a bigger eruption, okay? And it did go past the danger zone, and no, we did not get a radiation storm out of that. Whenever there is an eruption on that side of the sun, radiation storms become part of the conversation. And the reason why is because we're connected to the sun over here on this side. So anything that blows off on that side, anything that has protons in it, that line will catch it, and it can actually siphon it backwards and hit us. Okay, we've had massive blasts off the backside that we hit that would blast off the back, and yeah, and it would still give Earth a radiation storm, and it went completely the other way. So I just want to make sure you guys understand that. Now, so if we go back here and we'll look at the 14th, okay, this is from SOHO. This satellite sits right in front of Earth, 1 million miles closer to the sun. It is as if you walked outside and looked up. It really is. That's the perspective we got. And it gives us about an hour warning before things hit. Okay? That's not the reason they put it there, but it's there regardless. So this is the 14th. There's 1, 2, and then that eruption right there. And I'll slow it down again because I showed this to you guys yesterday, but the models are in now. See this? That's a halo. This is a real physical disc on the imager. So we can't see what's directly behind it, so we don't know if things are coming right at us or going off the backside if it happens right there in the middle. This here is the surface of the sun. That white circle is what it's representing. Okay? So when we see energy poking around, what happens? That it produces something that looks kind of like a halo. That's why they call it a halo eruption, or a halo CME, you'll often hear it called. And if you want to get technical, it's actually an ICME, interplanetary coronal mass ejection. It has to have that I in there because it means interplanetary, which means it actually left the sun. If it does not leave the sun, that's just a coronal mass ejection. It's still ejected, it wasn't enough to get away from the sun, and it basically got recaptured. And sometimes you can get eruptions in the sun that actually just will ripple across the surface like a big shockwave. We've seen that a lot. Filaments erupt. There's a whole lot of different things that can happen. But for what we're talking about here, this halo eruption is what we're going to be showing to point to the geomagnetic storm that's supposed to hit in a couple days. Okay, this right there, okay, that's what's going to be hitting us. And I know it doesn't look as impressive of what's going off over here, but this isn't coming our direction. This is because we can't. This right here, the center of that, is probably right here. So all the bright stuff is being blocked from this occulter disk. Okay. Now there are times we get an eruption and this looks like a halo, and people's butts start to pucker, and we start running over here looking this, that, and the third. And then all of a sudden we find out, oh, it went off the backside. Okay, so we have to check that. We used to have a side view, right? And it came from stereo A. This satellite right here on this same web page. Okay, this satellite is no longer 90 degrees. It used to be 90 degrees in our orbit, okay? It used to hang out over here. It doesn't do that anymore. It's hanging out here now. Okay, so I can actually show you that, believe it or not. Yeah, let's do that real quick. This is the NASA CME tracker, and this is the inner solar system. But you see this red box? That's stereo A. This satellite used to be over here. Okay, and so we got a backside view of the sun, and we could see what was coming this way, so we could tell if it was coming at us or going off the back. Now we don't have it over there. There's nothing over there to do that for us anymore. So what do we got to do? We have to rely on what we have, and what we do have is a satellite called SDO. This one here. Okay, this one's in geosynchronistic orbit. And actually, I can show you what that is just very, very quick. I'm not going to waste a whole lot of time explaining it. It's called geosynchronistic orbit, and it does this figure 8 pattern. It never moves from this spot. It orbits the Earth at 15 degrees an hour, the same speed that we go around our axis. So it keeps it over here. Now, one of the reasons they did that was to limit the time that the Earth will pass between the satellite and the sun. Plus, in this figure 8 pattern, it's always in a position to relay its data back down to white sands. So in other words, they can get almost immediate real-time data from this thing. That's pretty, it's not unique, but it was really unique when all this was first going on. There's a few more satellites out there now that can do that, but instead of having to go to one, relay it to the data to one satellite and then to another and then to the ground, that kind of thing, this one doesn't have to do that. So what happens is it rotates to keep its eye on the sun. You see that yellow line right there? And you see that's why they got the green line here too. It's telling you, hey, this is relaying its stuff back to here. So if you really want to dive into this, you can go look at this. But I'm not sure if we're still in eclipse season. If we are, we're coming out of it. Last week we definitely had some eclipses, and what that means is because of the satellite, the Earth would actually go between the satellite and the sun. Okay, so we would get what would appear to be missing data, and it's not. Things would go black, is what I'm trying to say. Okay, so let's go back here real quick. Let me go to the 15th here. This is today. Okay, there was a pretty decent blast right there, but that thing is not coming at us. Okay, right here. Now, also, you're going to notice this is a very, very slow-moving CME. That is not coming at us, so I'm not really going to dig too much into that. I don't want to waste your guys' time. But what I will say, that's pretty dense, and that's very, very slow. If that thing was coming at us, I mean, it would take probably 5 days to get here. And that is part of the window that they give us. 3 to 5 days is what, it's kind of what the window they give us to get a CME once it leaves the sun. But with that being said, we did have that X-flare, right? And it came from here. And I'm going to show it to you here in a minute, but this is breaking the law. This is breaking Hales' law, right? Hales' law, it basically dictates the polarity and where the polarity should be, positive and negative. In the southern hemisphere right now on the sun, we should see blue, red on this colorized magnetogram, okay? And in the north, we should see red, blue. So, what we're seeing, and this one here, I can't really tell where the core is, but this one here even looks like it might be reversed. I said this yesterday, but I can't really tell. So I don't know if they're considering that like a base core, that little red little blotch right there. So this may not be breaking the Hales law, but this one definitely is. And the reason I'm saying that, actually, I'm just going to grab this and we'll move it right here. Yeah, I think that one's breaking it too, guys. As I move that forward, it sure as heck looks like that's reverse. Yeah, look at that. We should be seeing red-blue, not blue-red in the northern hemisphere of the sun. So we got two rare types of sunspots on the sun all at the same time. I just noticed. I mean, I had seen that yesterday, but I didn't know if they were going to consider that a core. And they still might not, guys, so I don't know. But from what I can see, yeah. But anyway, this one is definitely breaking it because the polarities are north-south. It should never be oriented like that. We get about 3% throughout the sun cycle that breaks that Hales law. Okay? And these ones that not these ones. Speak English, Mark. My goodness. The ones that do, those are the ones that we really pay attention to because they get very, very active. Not only is this one being very unstable and complex, it's very active. It seems to be like it's getting deeper, like it's really holding on to what's going on here. Now here on the end, I guess those last few images, the red started to kind of fade out, but it's still showing some very good properties there to be able to blow X flares. Okay, so when you got it north-south, that's breaking that law. It shouldn't do that. I don't want to say shouldn't. It's unlikely that it should do that. That's what I would say, because you got to pretend there's a bar magnet on the sun when the sun cycle flips. Okay, when the sun cycle resets, it's a polarity flip on the sun. Okay, I explained this yesterday. Right now we got blue-red, right? That's the way it's supposed to be in the southern hemisphere. Well, when we get the pole flip, guess what? It's going to flip roles. So it should be red-blue in the southern hemisphere at that point. So you got positive, negative, in the equatorial regions of the sun. It rotates faster than the pole regions. What's that mean? Well, it starts to pull those magnetic lines. And that's why we start getting these lines of sunspots horizontal. And then they start migrating because things are progressing. The equatorial regions of the sun are going to continue to rotate faster, so it's a continual pull of those magnetic lines. And the lines of the positions of the sunspots usually start off about here, and they migrate through the sun cycle from both directions, and they meet in the middle. That's the termination event. Okay, that's the reset, and here we go. It's another sun cycle. That is a very basic whatever with that. But yeah. But anyway, Miss V, email me. I just seen that. Email me. We'll figure something out, okay? All right. Now, let's go ahead and let's go here. Now, what I want to do is I'm going to show you guys that X flare, okay? I'm just going to take you back and show you that X flare because here on SDO, and I'm going to show it to you with the 131 angstrom. They could give this thing any color they wanted, right? This is just this angstrom of light, and it sees a specific gas, and I don't know what gas this is, but we're able to look at different angstroms because it shows us specific gases, so it gives us different visuals, right? And it lets us see certain things on the sun that we typically wouldn't be able to see. So here's that one breaking the law, and it's going to fire an X flare here in just a second. Once this rotates, matter of fact, I'm just going to pause it and grab it. Okay, so there it is. Right? So, number one, there's your X signature, right? What I said earlier. Just because it looks like an X, don't make it an X flare. We have to have the X-rays. That's what determines how big a flare is. The amount of X-ray it produces. You'll see littler flares make the same signature. But this, and even though this flared, it doesn't have to produce a CME either. Okay? There's a difference between a flare and a CME. Dr. Carrington proved that back in 1859 with the Carrington event. That's when really sun science really started to make a change, because they started to understand, hey, we didn't know enough about what was going on, and you know, some of the things that we thought were true were not. And that's why we question what we know, right? What we think we know anyway. But we have to be able to accept it when it is what it already said it was. Plus, we have to be able to accept it when it's not. So it takes both. You can't be biased, is what I'm trying to say when you're talking about stuff like this. You just got to follow the science and move with it. That's all you can do. Challenge yourself and challenge other people. And don't be rude about it, and be polite. And I guarantee you, if you work with other people, you'll figure more things out a lot quicker, and it'll be a much better community for everybody. And that goes from the low-grade people like myself all the way up to whoever you want to talk about. I see people fighting all over the place, and I don't participate. I promise you that. Any of that stuff ends up in my chat. My mods know that that stuff just gets ripped off. It is out of there in a hurry. We're not allowed to say bad things about any other channel in my chat. I don't care if you guys think I like them or not. My mods will delete that stuff right away. Just so you know. Hey, Verte, good to see you, brother. Yeah, Miss V, please email me. That's not gonna happen. Just so you know, we'll figure something out, okay? So with that being said, that was that X flare, okay? That is, it produced that CME. Okay, I already showed you the CME. Here's the NOAA model for it. Actually, I'm surprised it still hasn't it's updated, but they just fixed this. They are forecasting it to hit on the 18th. Okay, early on the 18th. So that's what it is. Hey, Deep Quake, thank you for the gifted memberships, brother. Appreciate you. Appreciate you, man, for real. Whoever got those, I just seen that, guys. I'm trying to concentrate on doing this, and hopefully you guys are enjoying this. I do try my best. Hopefully you guys will appreciate, and I'll stop about halfway through and say thanks to everybody. As a matter of fact, guys, please go ahead and give me a roll call, and give me a roll call in there. Just give me a region, right? And I'll say thanks to Deep Quake and Aaron. You guys are awesome people. They've already gifted 10 memberships together. And we are doing a members only right after this. So just remember that. And thanks to everybody else. So give me where you guys are from. And yeah, and thanks to my mods. My mods are awesome, I just have to say. Best mods on the planet. And just that you guys really just are. So, but as you guys are doing that, I'm going to keep moving, okay? And I'll stop in there and we'll see where everybody's from. Well, thanks, Linda. I appreciate you. Guys, I really do appreciate the kind words when you guys send them to me. It is really what keeps me going around here. It truly is. If it was anything other than that, I think I probably would have gave up on this a long time ago. But anyway, just to give you guys an idea of this is that same big sunspot, and this is the latest imaging, right? Here's Earth scale. Check it out. This is Helio Viewer, and I just recently started showing you guys this. I've looked at this for a long time. It's just I just never really, I don't know why I never really showed it to you guys. This does give some really good detail too, because we can really dig into, we can get in here pretty close, right? Look at this. So this is your scale. This is scale, right? So you can fit Earth right in the core of that thing. Okay, I think this is just cool to show everybody, number one. And we'll get to the Venus thing here in a minute. Hey, man girl, where are you from? Yeah, I know. I'm going to say it to you every time you're in here. You know that, right? Western Kentucky, see here, think here. That's right. See here and see here, think. Miguel Cuevas, New Jersey. Good to see you. Gunslingers in here. Big Blue Rock, baby. Robert House. Thanks, bud. Appreciate you. Bradley Smith, Australia. Is that Australia? Not sure. Ricky's in here. That's right, baby. Good to see you, Ricky. Colorado, Nebraska, Joy. See here. Michael Klaus. Venus, so hot. Everything always melting. Exactly, man. Exactly. Exactly. Or is that Michelle? Did I read that wrong? I can't tell. I can't read my phone, guys. My eyes are horrible. So if that's Michael. Yeah, it's not Michelle. Sorry, Michael. Sean, what's going on? Eastern North Dakota? Deep Quake, yeah, whatever you're talking about's fast, I believe you. San Diego, Randy F. Mark Matheny, Virginia. Patricia, what's up from Washington? Mooshy Wooshy, love the name. Jen Tweedy, Colorado, baby. Heck yeah, Michigan, Beckinator. Magic Moon, DeLorean MB, baby. Delaraine MB. Awesome. Mary Gunn from Texas. Alright, guys. Thank you guys for doing that for me. I really do like to know where you guys are from. I know I can go look at my analytics, but I can't really put an account name to kind of like a region. I like to get to know as much as I can, guys, just so I can be a part of everything too. And that's just kind of what I do. Plus, guys, guess what? Believe it or not, just doing that roll call, that really, believe it or not, that actually pushes the video out, because you guys get in there and you start talking, and people are commenting and things, and it adds more to the chat, and the algorithm likes it. So, just so you know, it does help with that too. So there's multiple reasons to do it, and that's why I do it. And I think the way that I do it and say thanks right there, I think it's working out well. I'm able to stay focused and all that. I had a problem there for a long time, guys. You guys know I was squirreling really bad, and I'm not going to do that anymore. I've put some stuff in place with some advice from some really good friends of mine. Well, namely Dex and Adam and others. But yeah, great people over at Marfugal, you guys got to know. And again, my moderators are the best. So, and half of them moderate over there. So, yeah, or watch. Okay, so this is the data. The BZ, guys. The BZ is what is a very important data point. Basically, it's the magnetic direction that we point for our magnetic field. I'm not going to get into exactly how that works, but we look for -6. So when we see a -6 in the purple, that means that we're susceptible to dragging in geomagnetic activity. Anything coming from the sun, that's what happens. So if we're in that negative position, we can get into some pretty strong geomagnetic storming. Vice versa, when it's in the positive, when this red line's in the positive, we could be expecting a decent hit from the sun, and just this one data point, this BZ, being in the positive, will be enough to keep us out of geomagnetic storming. You'll still see the CME come in, because you can see it on the tools, but none of it's getting through. It's deflecting it. It's doing what it's supposed to do. It's protecting the planet, right? If you guys are wondering, this is the phi angle. Just a quick little thing here. That's actually the polarity of the solar wind itself. And again, I'm not going to get too much into that tonight. But the orange line is density, and then you got speed. Density, speed, and really the BZ is what those three data points combined is really what I look at just for a basic overall, hey, is this CME going to hurt? Is it going to hit us hard? What's going to happen? Those are the points I look at, right? But we don't want to forget the phi angle either, because you see where it flips from blue to red? When it does that, it can yank on us pretty good. And when it does, sometimes that's enough to put us into geomagnetic storm on its own. So, yeah. So there's a whole lot of moving parts going on here, guys. So when people get upset when the forecast is wrong, just remember that, you know. There's a whole lot going on, and especially during Solar Max. Now, you guys know I don't forecast. What I'm doing is nowcasting, and that's what I'm going to continue to do. I can't forecast. I'm not the man for that. But what I am the man for is understanding these models and what they're trying to show us, and giving you guys a good understanding of how the models work. That way, when you're listening to somebody else forecasting, you'll understand what they're saying. And I can give you the current conditions and show you what's up, and tell you what could happen with these conditions. So now, if there's a G5 storm or something coming, obviously I'm going to give you some sort of a warning for that. But you know, getting into some like technical forecasting, I can't do that. So anyway, I would love to be able to, and I'm trying to learn, but I'm not confident enough yet. I'll get there, I promise. Anyway, this is velocity. This is our magnetic field. It's called the magnetopause. This is the bow shock. That's the first point of contact, space weather, to our magnetic field. Okay? That's all that is. This is density. Same thing applies here. Now, every once in a while, you'll come over here, and you'll see that the bow shock looks like it's not there. All that means is the density is the same on one side of the bow shock as it is on the other. Okay, that's why you have to understand the model. If somebody tells you the bow shock's down, tell them to show you where the sun went away, or we completely lost our magnetic field. If either one of those two things happen, it's a really bad day for everybody. Just saying. Bow shock's not going to go down. Okay? The bow shock is produced, it's there from the first point of space weather from the sun and our magnetic field. The only way that goes away is if one or both of those other two things go away, and that would be a really bad day for all of us. Just saying, I wouldn't be here telling you about it, that's for sure. And I'll just leave it at that. But this is magnetic pressure. Okay, everybody understands pressure. This is magnetic pressure. Now, this right here is really going to show you if you're getting hit geomagnetically. This thing will light up red, and we did take a little bit of a hit right there. You see that? Okay, same thing. This is trying to represent the bow shock. It's not exact, but it's close. But anyway, there's your magnetic pressure. That doesn't look intense at all. So there's nothing going on at Earth right now with that. This is the geoelectric field. This shows us the geoelectric field at the surface. And what it's here for is to try to bridge a gap between space weather forecasting and earthquake forecasting. Right, the better way to say that is space weather's effect on unnatural electrical components such as switches, wall wires, anything. Your car battery, anything that ain't made by nature. Transformers, substations, any of that stuff. Okay? That's what this map is trying to show you is space weather's effect on those things. If they know that and they're able to get some detailed information, we know that space weather has an effect on seismic activity. It's an uptick, right? So what they're trying to figure out exactly why, and that's why the USGS and NOAA and the Natural Resources of Canada are working together now here to try to figure out exactly why. But what I can tell you is this. Let me switch this to, let's go to the 211 on this one. This is SDO again, guys, sorry. I thought I had this one pulled up and I didn't. I'll just pause it right here and we will go back here. Coronal holes. Anytime you got a coronal hole, we get an uptick in seismic activity. It's a fact. Okay? So, yeah. So when we have these coronal holes, we see an uptick in seismic activity. Look around. Go over to Ron over to Emergency Management Associates. He was doing a live stream earlier. Guys, I'm telling you, it's just the way that it is. I don't know why it's like that, but I can tell you that that happens. Every time we see this, we always see an uptick. It's in the data. Can't deny it. Now, like I said earlier, I can't tell you exactly how that works, but what I can do is tell you that, it is what it is. All right. So, again, with that being said, let's talk about Venus. You guys want to talk about Venus? That started the conversation even before the stream started. Okay? Once again, I want to give a shout out to Dr. Tony Phillips here. This is spaceweather.com. This is his webpage. I'm not going to read things word for word. Please come over here and read it and give him some traffic. This is how he makes his living, guys. Okay? He's actually talking about the same geomagnetic storm I was just telling you guys about here in this first article, right? But here's the story from Venus. This is a once-in-a-lifetime capture for this person. Okay? That's Venus. That's part of it getting ripped off. Okay? Yeah. So, I am going to read this one pretty much, not really word for word, but close to it. A blue flash from Venus. Well, I just reported, guys, on the green flash. And he actually explains to you why it's blue and not any other color. Okay? So here it is. Italian photographer, Paolo Palma. He was watching Venus, doing whatever he does, taking his pictures, right? And check it out. On August 12th, as Venus was coming down on the horizon there, a piece of the planet broke away and turned blue. Now, it probably didn't change color. It only changed color from our perspective. Our atmosphere changes everything that we see out there because of the way light works and gets bent. Okay? So with that being said, see, right here he's talking about green flashes. They're sometimes seen when the sun is setting at sea, right? Temperature inversions. In other words, just a variation in temperature and strong thermal gradients, again, If you guys break those two words down, I'm not going to throw word salad at you. You guys know I don't do that. I try to use normal words. I understand what this means. But if you break down thermal gradients, basically that is a gradual decline or incline in temperature. So you got a scale here that you can go off of. There is like a ruler or whatever you want to say, just some sort of measurement of the temperature, and it will graduate from one to the other, and it can bounce back and forth. Anyway, that probably wasn't the best explanation, but it's really how I got for you guys. Sorry. Matter of fact, that was pretty bad, just to be honest. Yeah, anyway, in air above the sea surface, split the sun into RGB colors. Okay, we all know what RGB is, right? Red, green, blue. So, you know, with those three colors, you can pretty much make any other color. Okay? I got RGB stuff on my computers, my keyboards, all that stuff. It's a aesthetic thing. But I worked in printing for 20 years. I can tell you right now, with those colors, we worked with what's called process printing, and true process printing is red, well, basically magenta, blue, you got yellow, and black. So when you got those colors, you can make any other color that you want with just the combination of all those. So it's cyan, magenta, yellow, and black is the words that they use. Now cyan basically is just blue. Magenta is basically a shade of red. I mean, we all know that, right? I mean, I hope we know that, but maybe you don't, and that's okay. But with working in printing, it gave me a really good idea how that stuff works. Now, your old TVs work the same way. All right? They're dots. And you guys hear me all the time over here talking about this. When I call it popcorn, it means it's bouncing all around, right? When I don't call it popcorn and it looks like a straight line, it means the data points are, because it's just a point, right? So if they're lining right up next to each other with the same reading, it looks like a straight line. But really, if you zoom in and look, it's still a dot. Same thing's going on with this, okay? When you look at your TV, that's what's happening. It's a bunch of dots getting moved around, different intensities and different shapes. That's what it does. That's how it works, okay? But anyway, the thermal gradients in the air above the sea surface split the sun into RGB colors and magnify the green into a dramatic flash above the setting sun. Okay, so because of the positioning and the thermal gradients and the temperature inversions, yeah, bunch of word salad there for you, that's why it showed up as blue. Okay, and he just happened to catch it when Venus was losing part of itself. Okay, so if you read down here, photographers are lucky when they catch a blue flash from the sun, even, right? Catching one from Venus is a once-in-a-lifetime shot. Okay, this is a rare thing, guys. It's probably not rare that gets ripped off of Venus, because Venus is different than us. But, listen, congrats to this guy. I mean, for real. That is an amazing thing to me. To have your camera in that position to catch a blue flash instead of a green. You can see where it tried to go green right there. So, I mean, it's just amazing to me. It really does. So, yeah, we're just going to leave it at that. So, yeah. Anyway, now, let me do something here, guys, real quick. I have to... Did I download those pictures? Guys, I didn't even download those pictures. Daggone it. Can't believe I didn't do that. I thought I was ready to go, but obviously I wasn't. I tell you what, we're going to do this. Let's do this here real quick. Let me, what I want to do, and you guys should still be able to hear me when I do this. I'm going to give you guys, yeah, we'll just let you look at this while I do this. Well, I'm probably not going to spend a whole lot of time trying to download things because it's just not going to be good. I'll tell you what I can do, though. That is, I will, oops. That wasn't good, was it? How about that? Is that a little better? Is that a little better, guys? Sorry. Sorry. What's it do when I do this? Yeah, we can live with that, can't we? For a minute? Yeah, we can live with that for a minute. Let's do this. Let me, I'm not going to be able to download them because it's just not going to work. Let's, I'll tell you what I will do, though. I can do this. Let's do this. Check this out. This one came from Ricky back during the... Ricky Spence is in here. That one came from Ricky back during the big solar storm. Here's another one. All right. Now, let's back that off. Let's try... There we go. We can do that one, too. Let's do this one. I think y'all seen this one. I think this is one of the most amazing ones I've ever seen. This one came from Ilea, guys. Let's go ahead and bring that back up solid like that. Guys, that was just a crazy one. If you look real close, guys, the Big Dipper's right in the middle of that. And again, I've already shown it to you. But Dennis, if you're listening to me, brother, I promise you I'll show him tomorrow. Miss V, thank you for helping him with that if you're still here. I wish I'd have downloaded them things. I feel bad now. But yeah, I'll show them to you guys tomorrow, I promise. But that is some of the stuff from just the other day. Ilea got some of them, and then who else? Who else sent them to me? I think it was from Northwest Ohio. Bill sent them to me. These here, okay? Check that one out. That's pretty cool, isn't it? Guys, I mean, send them to me, I'll show them, I promise. Just tonight, I just was so much all over the place. I just had so much to talk about. But yeah. Is this one yours, Dennis? I think this one's yours, isn't it? From the other day? Okay, cool. Cool. Awesome. Alright, cool. These are yours from the other day, aren't they? Yeah, these are very, very cool. I just want to see some of, with my own eyes one of these days. Just to be honest with you, I have never seen them with my own eyes, and it's here's another one from Dennis. Right there. I showed some from Ricky. Oh, we got some from Lord Kiss Freak too. You guys got to see these from Lord Kiss Freak. They are something to see. These here, I got one in my email that I can't pull up right now, but he works in Canada. He lives in Canada, so he sees these more often than most. But this is the kind of stuff he sees on the regular. So I wouldn't say regular, but he sees it more often than what we would. But he's got some, because he works in he does excavating. He's got Aurora with a backhoe in the picture. It's really cool stuff. I just find this stuff amazing. I know Ilea shares the same feelings for this, because a lot of you guys probably do, but I've talked to Ilea about this before. And it's just really cool stuff, guys. I wish one of these days I will. If not, hopefully on my way up, after my number's called, at least maybe I'll get to see him then. I don't know. But yeah, can you guys, this one here, the ones like this amaze me, because I couldn't imagine just, how can I say this? Just looking up and seeing that would just be so cool. But yeah, so let's do this, And let's do that. Okay. And why is that not happening? All right. So let's bring that up. There it goes. Okay. All right, guys. But that's pretty much all I got for you tonight, guys. I am going to be doing a members only here in just a minute. I'm actually late for that, just so you guys know. But just hang in there. And members only, members, anybody that's a member, if you guys want to come to the stream, please come on over. Just go ahead and join up in the chat. I'm getting ready to start it up here in just a few minutes. So we're going to watch a Zoom hearing, and we're going to see how that goes. Okay, guys? But thanks to everybody that came by. And guys, lots of stuff going on, and I'm going to try my best to keep you updated. Check that out. That's awesome. Ricky, good job. Everybody else, Dennis, thank you. Miss V, thank you. Email me, Miss V. We need to talk, okay? I'm not going to allow that to happen, just so you know. We'll figure something out, all right? But yeah. Okay. So, with that being said, God bless. Yahusha saves. And, yeah, you can drink this Kool-Aid.